Find the value of a that makes the function continuous everywhere. So we have ourselves a piecewise function. That's a mess, but it's over t squared. It tells you that t can't be 0. Well, it makes sense because if you were to throw in 0 for this guy, you would get 0 squared on the bottom, which is 0, which means you get an undefined function, which is impossible. So what's going to happen is you're going to get a graph of this, and you're going to have a hole or an asymptote of some kind or a breakage at 0. But I need to fill that 0 in. Now, I'm like, okay, well then find where things fall apart. Well, I can't just plug in 0 because it won't work. So what I need to do is I need to run to Desmos and make a graph. So I'm going to go to Desmos and do a graphing calculator. You could also do a regular graphing calculator, run to your own graphing calculator, but I'm going to graph this guy right here and see where my equation exists at 0. And then I'm going to paste that graph right there. All right, so if you take a look at my graph, and I zoomed in quite a bit, I typed this exact same thing into Desmos on my phone. I had to use X's instead of T's because that's all it gave me for the phone edition of Desmos. If I were to try to take my thumb, or if you're on a computer, take your mouse and hover over where X or T is 0, it'll say undefined. But if I get awfully close to 0, it'll tell me that t, or the y value, is 0.25. So in order to fill that hole in, a has to be 0.25. Right now, I see this weird image that looks like that, but there's a hole there at 0.25. By allowing a to be 0.25, it fills that hole in. Now it's continuous everywhere. That's my answer.